Hello all. So the objective of this program is to find the prime numbers from 1 to 100. As because we are not including the prime number as 1, I will be initiating from 2 to 100. So now I have to check. So we know that the numbers will be in the order, and we have to, if we need to go from the starting to end of up to 100, then I have to use for loop for that. Therefore, I'm initiating two values, one for either prime numbers and one no and one more for whether it is not a prime number. So therefore, I'm initiating I and j and then count for initiating the values, that is counting the numbers. If it is a prime number, then again it will be going. So for that I'm using a temporary variable here. So now initiating for I is equal to 2, I less than 100, I plus plus. So now it will be initiated as 2. Now the count is equal to 0, and here again j is equal to 2, j less than I, j plus plus. So here why I'm using j less than I is whether the same number is divisible by, if the same number, then it will be giving us 1 only. So it should not be considered. That's why I'm using this less than I. Only within that particular number only it is going to be divisible. So if it is going to be 15, up to 14 only I can divide it. More than 14, I cannot divide. After 15, it cannot be divisible. So I'm using for less than I only. And starting number from the same number I'm using. So here, now let's take an example as 15. So the count will be initiated as 0. And here, it will be initiating from 2. So first it will be checking for 2. And then it is checking for 3. And it goes for 4. And it goes for 5. So when it goes for 3, we can see that it will be divisible. So at that time itself, it will be initiating. When the I value, that is the 15, is divided by 3, it will be giving a remainder as 0. So at that time, the count will be equal to count plus 1, that is 0 plus 1. So it will be 1. So again, it goes for the next value. So each and every time it goes for next values. So for that, even we can give, even in the first numbers, if it is getting divisible, we can give a break here so that it won't go for the further values, and will be going out of the loop and go for the next value. And for example, if it is going to be 17, so now it gets divided by 2. Yes, it will not be. Then 3, it tries, and then 4, and then 5, up to, it goes on up to 16. So it goes on up to 16, and up to 16, it will not be divisible. So because it is less than I only. So now what happens here? It will be checking for the condition. The I is not divided by j. So this value is not divisible by j, and it will not give a remainder as 0. It will always give a remainder as 1 whenever it is divided by some numbers. So it will not achieve this particular count. So what happens? It will come out of the loop, and here it checks. Yes, whether the count is equal to 0 for that particular number, yes, then it will be added in this I value. So it will be displayed here. So when each and every time the numbers will be coming out and storing here. So that is what it happens. So that is why it is given in the within the for loop. So this loop first executes. This for loop first executes, and second this loop gets executes, and third this if loop gets executes. And for all the values, this if gets executes, and after completing it, it goes for the next value. If it is not working out, then it will go and store here. And after completing all the values for each and every number which is present in I, then only it comes out of this loop, and this loop will be initiated to the next value. So this is how it works for the prime numbers of about 1 to 100. So from 2, 3, 5, 7, 11, 13, 17, 19, so it goes on up to 97. So up to 100 we have given. So this is how it displays. Thank you.